1021.
Just for you.
So let's figure out. So find these values. So here's what I. Oh, it's like. I just. Where did I put it? I actually. Oh, it's right here. So here's what I know. If I set this equal to x, then I know b to some power equals 1. Okay. So if you ever have log to 1, no matter what, even on your calculator, log of 1 is always going to be 0. Always. Always. And it makes sense. Shh. Stop talking, Lana, please. Okay. So anything to the 0 power is always 1. So log of any base, log of 1 is always going to be 0. Always. Okay? It just makes sense. Because any number to the 0 power is always equal to 1. I'll say that. Any base to the 0 power is always 1. So if you see log base of 1, log of 1 is just plain old 0. In fact, you can try it on your calculator. Go straight to on. If I go clear, quit. If I go log of 1, always 0. Always. Doesn't matter what the base is, it's always going to be 0. Okay? This one's always going to equal 1. And it makes sense why it's always 1, because you've got some base to some exponent equals itself, right? Has to be 1, all right? Any number to the 1 power equals itself. So log of, so for instance, if I were to do log of 10, because the invisible base is 10, right? Log of 10 is 1, okay? Always. Now, this is always going to equal whatever the exponent is. And it makes sense because if I go b, if I set it equal to anything, let's set it equal to y, b to the y equals b to the x, then the answer is whatever the exponent is, okay? So anytime we have a base to the same number to the x, it's always going to equal the exponent. Okay, I'll give you an example. Okay, if I have log base 10 of 10 to the third, okay? It's always going to equal the exponent, okay? It's just going to equal 3 in that case. Now this rule is the same way. This rule is derived from the rule we just put, and so this is whatever the x is, okay? It's just one of those rules. It's derived because it's the opposite of that one. This rule seems really easy because if you got log of the same base of n and log of the same base of n, then what do you know? I mean, what seems obvious to you?
I'm confused.
Okay. Do you want me to back up or just this one? Okay, these are log rules. So one way to do this, to prove what this is, let me do it real quickly, Zoe. If I, do you want me to prove this one?
Yes.
Okay, so let's just make it equal to y. Okay, so b log b to the x. Okay, we don't know what that is, but let's set it equal to y. So whatever answer I get, whatever y equals, that's what this equals, okay? So let's rewrite this, okay? Let's go and rewrite from exponential to log 1, okay? So I go log of my base of my equals log of my base b of x, okay? So that means all of this is the same, so that means what it has to equal is y, right? And so we said y is equal to all of this, which is just x, okay? So whatever's here is going to be the answer, so it's just x, okay?
Oh.
Let me erase all this mess. And then finally, it's just really easy. These two have to equal. You've got the log of the base of n, log of the base of m, then obviously n has to equal m. I mean, it's just, you're not really supposed to just cancel them out, but let's just cancel them out and say, then, well, then n is equal to m, okay? Just like, and you know this one, if you have b to the x equals b to the y, you know that x is equal to y, right? Because you can cancel the bases, right? X is equal to y, okay? Now, logarithms, here comes the important stuff. If you never take calculus, then these rules are not that big of a deal. But if you take calculus, these rules are super important. And I'll give you an example. Okay? I'll give you an example. In calculus, and I'm going to erase this, you might get a problem like this. f of x is equal to cube root of x times x to the, or y to the 4th thirds divided by, say, z cubed, okay? So in calculus, if you had to do a thing called a derivative, you'd have to break this up and then do something with it, then break something up with this and then do something with it, then break something with this, and it becomes a really big, ugly problem in calculus. However, they learn logarithms. We use logarithms in calculus to make problems like this easy, okay? So, logarithms are exponents, right? So if I multiply, so if I have some logarithm of some base of m times n. So if I multiply bases, I add exponents. I'm going to say it again. If I multiply bases, I add exponents. We can expand this to log base b of m plus log base b of n. Okay, this is a real handy rule to have in calculus. So you expand it. Okay. Logarithms are exponents, so when you multiply bases, you add their exponents. That's what we just did. Logarithms are exponents. When you divide bases, so if you go a log base b of an m divided by n, okay? When you divide bases, you subtract exponents. So we're going to rewrite this as a subtraction. Log base b of m minus log base b of n. And finally, the power rule. If you take an exponent, log base b of m, if you take an exponent to an exponent, okay? If you take an exponent, because logarithms are exponents, right? You take an exponent to an exponent, you multiply the exponents. So we're going to rewrite this as, I sure can't land it. You can rewrite this as this exponent p times the log base b of m, okay? Now what is the change of base property? Okay, so am I going too fast? If I had log base b of m, okay? Now, our calculator does log base 10 and log base e, right? But what if it's log base 4, right? We can change it to log base 10. So we can take this as, we're going to write this as log of m over log of b. Okay, let me give you an example of this. This is actually a pretty important rule. So if I had log base 4 of 321, okay, here's my example. So we know it's 4 to some power, right? 4 to some power equals 321. I can do guess and check. We can use our calculator for base 10, right? But we can't use our calculator to do base 4. Well, you can, but because you guys found the button. But so what you can do is rewrite this as log of 321 over log of 4. Now, what's my invisible base?
10.
10. So then you can just take, and if you want to evaluate this, I would just take my calculator and go log of 321 divided by log of 4. Now what's my invisible base? Say it again. 10. And we get an answer of, boom, 4.16. So 4 to that power, whoops, back it up, 4 to that power should be 321. And it is, okay? Now, you guys have already found, if you go to math, let's see, I need a new calculator. Here's, I know, I'm not trying to cheat because you've got technology, right? So you guys have already figured out, if you go to math, thank you, Evan, the other day, and you go up, and where's my base? I thought it was in math. Wasn't it in math?
Yeah, when you go up 2.
Oh, I'm not seeing it in this one. Math, quit. Let's go to math. You said go up to. Oh, it's not in this calculator. This is an old calculator. Okay, so the old calculators wouldn't do it. And in the old calculators, the only way you could do this was by the change of bases. The new calculators, lucky you guys, they Okay, quit. Thanks. I'm going to totally clear this out. Yeah, see why you have to learn it? The old calculus wouldn't do it, right? But the new calculus, you can go, okay, I can do this math. And you go log base 4 of 321, and you get an answer, right?
Wait, how do you select log base?
Okay, so hit math.
Okay.
Go, you can either scroll down until you find it.
Or you go up.
Or you go up to, they told me, yeah, you go up to. And there it is. You got it. Lay
How do
it.
you click it? Like, do you just hit enter?
Enter.
Oh, okay.
Yep. You got it?
Yeah, thank you.
Yep. Okay, now, let's keep going with this. So, let's do some actual practice on this so you guys get the hang of what we're doing, okay? So, we got the rules. Let's practice the rules, okay? And then we'll do some work. All right. Oh my gosh, seriously?
Seriously.
All right, then I better get going on this.
We got a test on Friday.
Yeah.
On my bars.
We spent so much time on that puzzle, didn't we?
Yeah.
I'm not ready for it. I'm practicing today.
I don't think I'm ready either.
Well, then we better get ready for it, huh? All right. What's going on tonight? We could always do math night tonight if we have to.
I'm down.
What is going on tonight?
I know we're going to watch Survivor. We are going to watch Survivor. That's tonight for sure.
No, wait,
But that's not
doesn't it
till
air
later.
on Wednesday?
Yeah, but we're behind. Okay, here we go, you guys. So, let's go ahead. And now, on number one, it's this easy. Watch. So what you see, do you see the plus sign? So, bring it together as multiply. Okay? Bring it together, multiply. So we're going to rewrite this as log base 4 of 2 times 32. Okay? So if you see the plus, logarithms are exponents. And when you when you multiply bases, you're adding exponents. So I can bring it back, and that's the same thing as log base 4 of 64, which is 3. Because 4 to the third power equals 64. Okay, example 2. Do you see the subtract? So I'm bringing it together as divide. So go log base 2 of 80 divided by 5. Okay. That's log base 2 of 16, because 80 divided by 5 is 16. So that answer is 4. It's 4 because 2 to the 4th power equals 16. Okay? Now C. This was an exponent that was brought down. So if I take a look at my rule, if I have a number out in front, it was originally an exponent. See how that? I've got a number out in front. It was originally an exponent. See how that rule works? So I'm going to rewrite this as log base 8 of a negative 1/3. Okay? That's going to be log base, oh, there's no base, of 8. Well, let's make this a cube root. Oh, I'm messing this up. Let me rewrite this as 1 over the cube root of 8, which is 1/2. So I'm going to get a log of 1/2. I need to rewrite that one. I'll come back and rewrite that one tomorrow. I don't like that answer. It needed a base, and I didn't give it a base. It should have base 4, something like that. I'll rewrite that one. Okay, D. Do you see the plus?
Yeah.
Well, I can't add them because they're different bases, okay? But I might be able to figure out what this one is, right? So 2 to what power equals 32? 2 to what power equals 32? 2 to what power equals 32?
4.
Thank you. Okay, 2 to the 5th power, that's 5. And then 3 to what power equals 81?
4.
4. 5 plus 4 is 9. Good guess.
That's it.
That's it. Example 2, we're going to do just the opposite. We're going to do just the opposite. We're going to expand it. So if it's multiply, it's add. If it's multiply, it's add. So I'm going to rewrite this as log base 2 of 6 plus log base 2 of x. That's it. That's all I need.
That's it.
That's it. And when you take calculus, that's a handy thing to do. It really is. But you don't know why yet, and I don't need to teach you. Mr. Massey will teach you why, okay? 5. Again, this is a really ugly problem in calculus. But in calculus, we can simplify it by expanding it. So first of all, we're going to rewrite as, if it's times, it's add. If it's times, it's add. If it's times, it's add. And there's a little times symbol right there that we don't see. Log base 5 of x cubed plus log base 5 of y to the 6. Okay? So if it's multiply, it's add. Okay? It's multiply, it's add. I'm going to squeeze this one over here. Now, if you are, yes. So now, if you have an exponent, if you've got something to an exponent, you can bring the exponent down. See how we brought it down? See this rule right here? If we have an exponent, we're going to bring it down. So I'm going to rewrite this as a 3 times the log base 5 of x. I just floated the exponent down. Plus 6 log base 5 of y. Okay? And you don't know why we're doing these until you take calculus and start doing things called derivatives. None of this really matters. But when you take calculus and you do derivatives, this is going to be one of the tricks you're going to need to know. Okay? And C, I'm going to try and squeeze it up here. Sorry. I'm going to first rewrite it as this. ln of A plus ln of B plus, because I timesed, right? Subtract, because I heard you said when you divide, you subtract. Isn't that what you said, Sky?
Yeah.
Subtract ln of the cube root of C, right? Yep, sorry. Now do one more trick, which I think you guys can handle because you're smart. This is a 1/3 power. You okay with that being a 1/3 power cube root? You okay with that? And that's an exponent, so we can float it down. So we're going to rewrite this final answer, ln of A plus ln of B minus a 1/3 ln of C. Okay? Again, I'll say it for probably 10 times because I repeat myself. These rules might seem kind of silly, like what is the point, Mr. Davies? But honestly, when you get to calculus, you're going to want these rules. Okay? Turn the page. All right. Now, let's combine them, okay? So this 3 is a number out in front. It was an exponent. So let's bring it back in. Let's write this as log of x cubed plus this 1/2 was an exponent. Let's bring it back in. Plus a log of y to the 1/2 power minus this 2 was an exponent. We'll bring it back in. Oh, a log of z squared, okay? Now, how am I doing? So far, so good? If it's plus, we're going to bring it together as times. And if it's subtract, we're going to bring it together as divide. So let's rewrite this as a single logarithm. I'm going to go, okay, log of, you ready? X cubed times, I'm going to make that, you okay if I make that a square root? Times the square root of y. If it's subtract, it's divide by z squared. That looks nicer, doesn't it, than that expanded thing? Okay. B.
Wait,
Yeah.
never mind, I got it.
Okay. B. We're going to, this was an exponent, right? Let's bring it back in. So I'm going to go ln x cubed. Plus, this was an exponent. Let's bring it back in. ln of y to the 1/2 power. This is 4 was an exponent, so minus ln of x squared plus 1 to the 4th power, okay? If you see plus, multiply. If you see subtract, divide. So as a single log, I'm going to go ln of, let's see, of what? Of x cubed times square root of y. Nobody's bothered by that, right? all over x squared plus 1 to the 4th power. Okay, you ready? Let's see if we can have a race. So, old school, I would change this to log base 5 of 30, right? You with me? And you guys could go find your calculator and you could try and go to the log base, but I'm just going to go, okay, I'm going to go real quick. I'm going to go log of 30 divided by log 5. Same answer you're going to get. Okay, see I did it? As you go to your math. How come I'm not? So I got the old calculator. See, the old calculator, you had to do it my way, right? On the old calculus. But you guys can go to, oh, that's an old one too. All right. Go math. Math. You guys aren't going to do it my way at all, are you? You're going to go log base 5 of 30. And we get the same answer, right? Same answer. 2.113, 2.113, okay? 2.113, okay? Okay, how about log base 8 of 5, right? I could go log of 5 divided by a log of 8. Or you guys are going to use fancy calculators, aren't you? And just type in, you guys just type in log. Oh, I got the old, no, that's a new one. Cool. Got a new one. Math. Log base 8 of 5 at about 0.774, okay? All right, last but not least, C. Don't multiply. That is not 3 times 2. You cannot do that. Your Aunt Sally's going to be really upset. You can't do that. So what should you do with the 3? What should you do with the 3?
Move it to the other side.
Yeah. We're going to divide. Is that what you're about to say, Morgan? Were you saying divide? Somebody over there was saying divide really quietly. Divide. Let's divide by 3, because Makai was right. To the x equals what? 9. And then what? Log base.
Log base 2 of 9.
Can you do that?
Yes.
Sure. Go to your math, log base 2 of 9. I can answer about 3.17. Okay. Seem pretty easy?